Good evening again. So right now we'll be doing the frictional forces. So as I've said earlier, we have the static frictional force and the kinetic frictional force. So now we are going to start with the static frictional force. So what is a static frictional force? This one is a force that opposes motion on stationary objects. So you can just say it applies to stationary objects. You see? So the static frictional force, it is the one that is applied on the stationary objects. It is the friction that occurs between stationary object, and then it has this equation that you have to know. Fs, it is the force of statics. So I always tell you the subscript, and this one is the force. Fs max, it is written as max. It is equals to mu s times n. So this n is the what? Is the normal force. Is the normal force. This n, this big N. Okay. So let's talk about this mu s. This mu s is a coefficient of the static friction. It is the coefficient of the static friction. That's what you have to know about the mu s. And then another thing that you have to know about the mu s, it is a what? It is a dimensionless number for different for maybe different surfaces objects, maybe wood to wood or wood to metal. Also depends on the surface preparation. Like it occurs between the block and the surface it is on, whether wood to wood or wood to metal or whatever. It depends on the surface preparation. Okay. And then number 3 that you have to know about this mu k, the mu s does not depend on the mass, or surface area of the object. And then what you have to know, this is very important, mu s has a value of 0 less than it is represented like this. So it is 0 less mu s less than 0, and then less than 1,5. So it means this mu s is less than 1,5. It is less than 0 and less than 1,5. This is the typical range from 0 to 1,5. So if you see a mu k, I'm used to the coefficient of the kinetic friction. If you see your mu s greater than 1,6, no good, there's something wrong. And then let's continue. So since my formula is Fs is equals to mu s times n, to calculate it, I will fuck up my value. Let's just I want the what you call the static friction, and then maybe my mu s is 0,15, and then check if there is no force applied on that a certain block. I'm just gonna say times mg, because what did I say? I said Fn is equals to mg when there is no force applied or something, about if there is no vertical force. You understand? So that's how you will do that. This normal force, you will take it back to what you were doing in the previous video. This is the normal force, so you must know what you must do. Okay, so let's continue. I want us to do this thing. So now let's come to the calculations. When we do the calculations, that's when we'll have to apply the Newton's laws knowledge. Okay, so check. Let's just say we have this thing. My example again, I love this one. So this is the one that I will use. This is the question that was written by the grade 12s for prelims this year. So I'm just using this as an example. So check. Let's just say they want the static friction that is acting upon the 5 kg block. What you will say, you'll just say Fs, it is equals to, okay, did they give us anything here? So they didn't. So Fs, it is equals to, I'm gonna assume. So let's just say, okay, we'll just do it like this. I will substitute only, I will not calculate. Fs is equals to mu s times normal, mu s times, okay, wait. So in place of the normal force, I'm gonna go to my free body diagram. Remember, Wuti, for the normal force, I take the two vertical forces and one weight, and the last force, which is the weight. So remember, it is being pulled. So I'm gonna say mg minus force applied sine theta. Then that's when you will substitute and find your static friction. I'm not gonna go back there and explain. You must go back to the previous video and know what I'm talking about. This normal force will be replaced by this, since I told you, since the object is being pulled, it will be minus force applied sine theta, because mg and force applied will be moving in different directions. Okay, so now let's do another scenario. So if it happens that I have this block here, 2 kg, I love it, 2 kg, ne? And they want the static friction, so it will be static friction is equal to mu s times normal, then it will be mu s times mg. Then you calculate and get your answer. The reason why I'm saying times mg, it is because the 2 kg doesn't have any force applied, anything applied on it, so it will be Fn is equal to mg. So the last one will be the one whereby the force is being pushed. So you will do it like this: Fs is equals to mu s times normal. Continue. You figure your mu s. You'll be provided the mu s. Sometimes you'll be provided to calculate the mu s. Sometimes you will not be provided with the mu s. You'll have to calculate it. But most of the time you are given the value for the mu s times what? Now the object is being pushed, so it will be mg plus force applied sine theta. You understand? So that's what you must know. Okay, now since we know what that's how we must do things, let's go to the frictional force, the kinetic frictional force. So the kinetic frictional force, it is now being applied when the object are in motion. It opposes motion. Okay, so the equation, it is Fk, it is equals to mu k times normal. It is just similar to the static friction, just that the difference are it is that this one opposes motion of moving object, and there is a mu k here. Okay, so let's deal with this mu k. We know what the n is the what? Normal force. Okay, it's fine, that's fine. So then what you must know again, you must know what the mu k is the coefficient of a frictional force. See, this is a force, so kinetic frictional force is Fk. It can be written as Fk. Okay, the number 3 that you have to know about, the number 2 that you have to know about the very same mu k, you have to know what the mu k, it is similar to mu s, but it is less than mu s. You see, that's what you must know about the kinetic frictional force. Okay, then I will do more videos for the kinetic frictional force on an inclined plane. Now we are still dealing with the horizontal surface. This is the last video whereby I will be doing things on the horizontal surface, and then I'm done for now. Then thank you guys. Don't forget that where there is the normal force, you check whether it is being pulled or pushed. Don't forget that, please don't forget that, because you will substitute the normal force with what you know. So what we can say for today, we did the static friction that occurs when there is in the stationary objects. It is fs max is equal to mu s times normal. Kinetic, Fk is equal to mu k times normal. And then mu k or mu s doesn't have a unit. If it is 0.15, it is 0.15 j. Mu k or mu s is equal to 0.15. That's how we do these things. Okay guys, thanks.